Okay, so today we're going to dip our toes into the finance section of higher applications, and we're just going to jump straight in, I think, with an example. So Oliver deposits £80 into a savings account. The effective rate of interest is 4% per year. Find the amount of money in the account after, and the first question asks you for about 4 years. Now, if this looks familiar, good, it should, because this very first question that we're going to look at is actually a National 5 question. Okay, it's a fairly simple thing. What you do is you take the initial amount of money that you started with, and then what you do is you multiply it by a decimal multiplier. Now, the decimal multiplier, it's not going to be 4% because we're actually increasing by 4%. So again, if we go back and just sort of think about what it is to increase by 4%, if you start with 100%, okay, your £80 is your initial amount, your 100%, and you increase by 4%, then what is your new percentage? Well, you're shouting at your screens, you're saying, well, it's 104%. So we're going to times £80 by 104%. Of course, we're going to write that as a decimal because that's the easiest way to do this on a calculator is to write 104% as 1.04. And if I type this into my calculator, what that would do is that would raise £80 by 4%. But that's not the question. The question says to do that for 4 years. It wants compound interest for 4 years. So I'm not going to multiply it by 1.04. I'm going to multiply it by 1.04 four times for all 4 years that this money is sitting in that account. And you may have seen, depends who your teacher was in National 5 maths and what you've seen before, but sometimes you'll see this written as a formula. Writing the formula incorrectly here. The formula is sometimes written as this: the amount is equal to the principal amount, what you started with, multiplied by 1 plus plus the interest rate to the power of n is the number of years. Now, if you've seen this formula before, great. This is essentially what we've done here. I'm going to shy away from this formula, and because I think it overcomplicates what's a relatively simple thing, which is take the amount of money you've got, multiply it by the multiplier that you need, the 4% in this case, and do it for the amount of years that are required. Okay, you put that into your calculator, £80 times 1.04 to the power of 4, and that's going to be equal to £93 and 59 pence. Okay, and again, that's just a National 5 question. So what we're going to do now is see how this develops here at higher and what's different. And you probably, cast your eyes over here to see where we're going. And you can see the next question says 6 months. So let's have a little think about 6 months. We're going to have £80 to start with. We're still going to multiply by 1.04 because our interest rate's not changed. Our interest rate's still 4% per year. It doesn't matter that we're only putting it in for 6 months. And now we're just going to ask ourselves, what's the period of time involved here? Well, it's 6 months out of 12 months. Right? Our interest is per year, and this is in months. So we're going to just have to convert this into years. 6 months is half of a year. And so my index, my exponent, is going to be 0.5. And that is how you work out compound interest when it's less than the actual period of time that we're interested in. In this case, it's half of a year rather than a full year. If I put this into my calculator, I get my answer of £81 and 58p. Let's have a look at this question. 6 years and 3 months. So my initial amount has not changed. My initial amount is still £80. My multiplier has not changed. This interest rate hasn't changed. It's still 1.04. It's still an increase, as we saw up here. It's still an increase of 4%. But now it's 6 years and 3 months. So what we need to do is just rewrite this in years. What's 6 years and 3 months in years? Well, we'll just have a little think about 3 months. 3 months, 3 out of 12 is a quarter. 3 months are a quarter of a year. So this is going to be 6 and a quarter. So this is going to be 6 and a quarter. So I'll write that as 6.25. £80 times 1.04 to the power of 6.25, and that's going to be equal to £102 and 22 pence. And there we go, we've answered the question. So the key idea here for this question, it's all relatively straightforward apart from just working out what the index is. The index in this question was 4 because it's 4 years. Okay? 4 years, we're already dealing with years, so it remains a 4. This question, 6 months. 6 months in years is a half. 6 years and 3 months is 6.25. And that's really what you're trying to do. You're just working this out. Okay, we'll look at the next example as well just now in this video. Okay, Ella wins £400 from her premium bonds. She puts the money into a savings account with an interest rate of 2% per annum. This means per year. How much interest will she be due after 5 years and 9 months? So it's not how much money will she have, it's how much interest has she earned in that time. Let's set this out. So we've got £400 is her initial amount, her initial capital, £400. Our multiplier, so if you've got 100% and you add 2%, you've got 102%. That's 1.02. And the index is going to be 5 years and 9 months. So let's express 5 years and 9 months as just purely out of years. What is 9 months out of a year? Well, 9 months out of the 12 months in a year would just be 3 quarters. So 5 years and 9 months is actually just 5 3/4. Again, you could type this as 5 3/4. You could type it as an improper fraction. You could type it as a decimal, as I've done here. So that's £400 times 1.02 to the power of 5.75. So after that period of time, she would have £448 and 24 pence. Again, we're not going to forget this, are we? The question is asking us about how much interest she's earned, not how much money she's got. Well, this is fairly straightforward. She started with 400. She ended up with 448.24. So her interest that she's earned is going to be £48 and 24 pence. Okay, I've just subtracted 400 from this amount here to get that. Okay. Let's have a look at this example, example 3. I think we've just got time to have a look at this one in this video. Okay, Amber has £450 to put into a bank account. She plans to save it for 4.5 years. Okay, I might just write that down here. 4.5 years is going to be the period of time that we're interested in. Kirkcaldy Bank offers an interest rate of 4.7% per annum. Kingdom Bank offers an interest rate of 2.8% per half year. Which bank would give Amber the best return? There's actually quite a few ways to do this question, but we're going to I'll focus on one method for this video. So what we'll do is we'll use this £450 in the calculation. So let's have a look. What we'll do is we'll start by looking at Kirkcaldy Bank. So the Kirkcaldy Bank would give her £450 as her initial capital. That would be times by a decimal multiplier of 1.047. Okay, so this is this interest rate here. To the power of, well, this is per year, and she wants to put the money away for 4.5 years. So this would actually be 4.5. So this is relatively straightforward to work out, I think. £450 times 1.047 to the power of 4.5. So Amber's going to end up, if she uses Kirkcaldy Bank, with £553.32. That's what she gets. Okay, so what we'll do now is we'll take a look at Kingdom, and we'll see how Kingdom Bank measures up to that. Okay, so again, the initial capital is going to be the same, £450. Now the interest rate, of course, is different. The interest rate is going to be 1.028. And you might be tempted to say that the index is going to be the same because she's still going to use 4.5 years. But let's just be careful here. This interest rate is per half year. So in other words, how many half years are there in 4.5 years? How many half years are there in 4.5 years? Okay, so just make sure you're happy with that distinction there. Although the period of time is the same in both cases, the index changes because these are not to the same time period. This is per half year, this is per full year. So we shouldn't be surprised that this is double the 4.5 we see. Okay, again, we just type this into our calculator now, fairly simple. Okay, and if I've typed this correctly, you're going to get £576 and 97 pence. At this stage, it's very clear that the best bank would be Kingdom Bank because she's got more money in there. Okay, so the question says which bank would give Amber the best return. So it's just a case of saying Kingdom Bank and giving some sort of working out to show that. They could they could have asked the question as how much more money would she have if she used Kingdom Bank. So we could do a subtraction here or various other questions. What we'll look at in the next video is a different way to answer this question, in which we don't actually have to use the £450 at all. But I think that'll be enough for today.